Hey everyone, welcome back to the channel. Today we are bridging the gap between theoretical electronics and practical simulation. We are going to build and compare half-wave and full-wave rectifiers in MATLAB Simulink. And then we will see exactly how adding a capacitor filter transforms a pulsating mess into a clean DC signal. Whether you are a student or a hobbyist, understand how to model these in Simulink is a vital skill. Let's jump into the MATLAB environment and get started. First, open MATLAB and hit that Simulink button. We are starting with blank model. To build our rectifiers, we will be using the Simscape electrical library. I will be using the Power System Specialized Technology blocks because they are incredibly robust for power electronics. To build a half-wave rectifier in MATLAB using the Simscape electrical library, you will need a specific set of blocks. These blocks emulate real-world power electronic components. First, we need AC voltage source to provide the input sinusoidal signal. By double click on this source, we can change the parameter of this peak voltage. Let it be 230 volts. Next, we need diode. Diode is the heart of the rectifier. It allows current to flow in only one direction, blocking the negative half cycle. Later, we need a series RLC branch. Set this resistive to act as your load. Now we need measurement devices like current measurement, which will be in the series to the circuit, and we need voltage measurement to measure the AC voltage and also to measure the DC voltage. Now complete the circuit like a half wave rectifier circuit. Now we need a electrical reference ground because every Simscape circuit needs a common reference point to solve the nodal equations. Now place the voltage measurement devices to the voltage sources. Similarly, if you want to measure the DC voltage, we have to check voltage at the load side. In order to see the voltage plot, we need a device block called as scope. Power GUI. This is the most important block. It must be present in your model to initialize the solver for power system simulations. After placing the Power GUI block in your workspace, let's run the Simulink. Now click on the scope 1 to see the input AC voltage in sinusoidal form. So we can observe the input voltage sinusoidal waveform. So this is VAC. It's a 230 volts 50 Hz pure sine waveform. Let's check the output waveform at load. Click on the scope 2. Here you can clearly see the pulsating DC voltage. During the positive off cycle, the diode is forward biased. It acts like a closer switch. The output plot follows the input almost perfectly. You will see a smooth hump on the graph. When the diode is reverse biased, it acts like an open switch, blocking all current. The output plot drops to 0 volts and stays perfectly flat along the horizontal axis. Now we introduced a capacitor filter. If you add a capacitor, In parallel with your resistor, the plot changes drastically. Instead of dropping to zero during the negative half cycle, the voltage will decay slowly in a diagonal line. So we can clearly observe the gap is filled and the waveform looks like a jagged line sawtooth near the top of the peak. This is known as the ripple voltage. Now we will design a MATLAB Simulink for the full wave bridge rectifier. To do that, we need four diodes. After completing the modeling of full wave bridge rectifier, now run the Simulink. So the input is pure AC sine waveform of 230 volts, 50 Hz. Now click on the DC voltage. You can see full wave rectifier work on both positive half cycle and negative half cycle. The rectification is done fully, and we can see 81.2 efficiency of rectification. Now we add capacitor filter to remove the AC component in the DC voltage, which is pulsating DC voltage. Now run the circuit to see the ripple voltage. Here the ripple voltage, pulsating DC voltage, is now became ripple voltage. Thank you.